Hi, I'm Sandy. So I'm here today. I got invited because I'm having 15 minutes of fame because I wrote a book. Which is kind of cool. So the book's about object-oriented design. Lots of you guys already know a lot about design, I think. Some of it more formal, some of it less formal. The talk I'm going to give you today was actually a talk I gave a couple weeks ago to the kids at Hungry Academy. And I realize that you are a completely different audience. I think, so I'm inflicting this upon you, not because I really feel like I'm going to teach you something, but because I want to make you evangelists for a certain point of view. It's been really interesting to me. I've been in the Ruby community, the Ruby Rails community for 6 or so years now. And for many years before that, I wrote Smalltalk code. It feels like the battle about OO design is just now arriving in Ruby. I have an opinion about why that is. I believe that dynamic object-oriented languages are so easy and forgiving, and Ruby is such a delight to write code in. If you can string logical flats together, you can use the Rails framework and make a web app. However, though it is really easy to write an initial object-oriented app, you can easily get yourself in a position where your life sucks later. And there wasn't much interest in the underlying principles of OO design early on in the trajectory of the Rails popularity. And now there are lots and lots of apps that are just killing people. And some folks in our community are holding up the principles of object-oriented design as a solution to those problems. As that banner has been raised, there have been some very, very significant voices, DHH among them, who have adamantly opposed the idea that object-oriented design is a good thing or that it can help these apps. I wrote a book about design. I clearly have an opinion about this issue, and I want to convince you that my opinion is correct and send you out in the world to testify. Using language like that makes it seem as if this is a religion. In my opinion, object-oriented design is a religion a lot like Unitarianism. Everybody's probably right. And so I want to find a way for us as a community to use what works, especially for the newer people who are having trouble with their apps, in a way that suggests that the ideas about design and our opinions about design, it's a really big tent, and that we can all be right. Like, I'm not interested in a big fight, but I am interested in helping people with apps, with principles that are going to improve their lives. When I was trying to figure out what to say to them, like, I realized that my thoughts about design, like, I have a bunch of circular, muddy sort of arguments. And it's really important to understand, to separate one's point from the arguments. And in an attempt to sort out my thoughts, I tried out a tool called mind mapping. So do some of you, who's seen a mind map? So you're somewhat familiar with them. What I have is a big mind map that I think talks about, it's my definition of design and some descriptions of where in your app design might be important. I sat in on the call to whatever the name of the project.
Social Mind.
The Social Mind call this morning, and I was really struck by part of the quality of the conversation they had with the customer about one issue. And so there are like places in your app where it really matters that you follow the principles of design, and places where it matters less. And knowing how to recognize those places really gives you a leg up in terms of identifying where you should concentrate your energies. And so we're going to have, I have a few canaries, you say, canaries in the coal mine, that will tell you where you should pay attention and where it doesn't matter so much. So my first question is, why should you care about design? And for you guys, you're in an interesting business. One of the first questions I asked Matt and Kevin this morning were, if you just wrote new apps and threw them over the wall, or if you ever had to do maintenance on, if you maintained your own apps. And as a consulting shop, my guess is that you're very much in the pattern of throwing apps over the wall, and not so much in the pattern of doing existing maintenance. Though I have to say the work we did this morning felt much more like maintenance than like writing new features. Years ago, I worked for a business much like this back in the day, And I worked on your side of the fence where I was a kid. So the bosses went in a room for a couple days and they made a spec and they brought the spec down to us and they said, write this code. And we did exactly what it said. We never deviated from the spec. This was pre-Agile, because if we did, we would be late. And we all know the bargain, right? If you're late, it's your fault. But even if you change the spec because it didn't work, if you're on time and it doesn't do what it's supposed to do, it's their fault because they told you wrong. And so we were very, very careful never to be late, even if the apps didn't work. I would have told you then, from my side of the fence, I believe myself to be a good, well-intentioned, ethical programmer, and I was convinced that we were doing the best thing possible for our customers. And then I went to work for a customer and had to maintain some of those apps, and I was appalled. And it was a shock to me at that time because I really did truly believe that we were doing the right thing. Now, I'm not saying you guys are doing the wrong thing. I'm just saying that shift in perspective was a real eye-opener for me, and it gave me a lifelong appreciation for the downstream costs of changing code. We didn't know them, and we were delivering apps that really were impossible to change. So now what I'm saying is, I think the point I'm making there is that for any app that lives beyond the delivery of the initial beta, the cost of change will in some time frame eclipse the cost of the original app. And it may be that the time frame you're considering is so short that you don't care, right? If you're going out of business unless you deliver today, who cares? Just throw some crap, throw some spaghetti at the wall and get it out the door. However, there is a time frame, and for good designers, that time frame is very short, where arranging code according to the tenets of OOD will save you money. And the time frame is always part of the equation. Change by definition is unexpected. Had you known you were going to have to do it, you would have written that code to begin with. And so by definition, it doesn't fit in your code. So every change that comes in, every change that you're asked to make is a chance to be asked to write code that doesn't fit into the existing arrangement. So from there, if I can find my mouse, we're going to go to what design is. So there's a lot of different definitions of object-oriented design, and I have a very simple definition for it. How your code is designed is how it's arranged. And that's all there is to it. The structure of your code is its design. And if that's true, then the designer is you. It's you. You're the designer. It doesn't really matter if you have a more senior person saying, oh, you should think of the structure, you should do it. It's like the guy with their hands on the keyboard is the one who's doing design. And that means that you're always doing design every time you write code. And so because of that, wait, I knew this was going to be a problem. Can anybody see my mouse?
It's not on the screen. Oh,
Huh?
no, it's just...
Wait, it should come across the...
It's down the bottom left.
Is it? Oh, there we go. Okay, gotcha. So because... I'm just going to have to put this screen over there. So, all right, so before I said design is the arrangement of code, and that the problem with change is that it's a chance to need new code that won't fit into the existing arrangement. And you can just rephrase that and say the problem with change is it's the chance to need new code that won't fit into the existing design. Those terms are synonymous. And so you're always doing design. The question isn't whether you're doing design. The question is, are you going to regret your design choices later? And so the goal of design is for you to understand the consequences of the choices you're making. If you know alternatives about how to arrange code, then you can predict the future cost of making change in that code. And so we have... So now we're having a fight in the community about design. Some people say that, so first of all, why are we having this fight? Like you can either say, those people are stupid, they don't know, right? That's one way we can characterize the argument. I'm right and they're wrong. Or we can say, everybody involved in this argument is well-intentioned and smart. And so there's a communication problem here that we can bridge. There's a gap that we can bridge. There's some way in which we can phrase this conversation so that we can understand each other. When I ask people, when I heard the DHH talk on Ruby Rogues and listened to what the reasons he gave for not liking design, when he said, I don't like design, design's bad. And then he elaborated on it and he said these two things. He said design raises costs. And he gave these two examples of how. He sees unneeded code that was written for anticipatory reasons. He goes in an app and there's code that's not being used. Someone guessed the future and they wrote code to meet it. And that code is costing him money in the present. That's one of his complaints. His second complaint was maybe there's not extra code. Maybe all the code that's there is being used, but some of that code is arranged in unnecessarily complex ways because of guesses about future requirements, and that complexity is costing me money in the present. Well, yeah, right? When people, if someone says I hate design, and they give you those reasons, what you do is you agree with them. Those things are bad. You should never write code that's not. There should be no code in your apps that's being used for anticipatory reasons. You cannot guess the future. You will always be wrong. And then when you add complexity to the present to do a thing that you guess will arrive in the future, it's always going to cost you money. And it's really hard to take that code out, to throw that code away. Believe me, if you write extra code or if a feature goes away and you have extra code that you don't need anymore, you can get it back out of revision control. Since you are almost always wrong about the future, it is better not to have any of that code. And people who do that and call it design, give design a bad name. I don't think of that as design. I think of that as just bad programming practices. Okay, so the other thing David said, so he said that, and I completely agree with him, 100% agreement, don't do it. He also said that you should never spend one moment thinking about future maintenance, the cost of future maintenance. I completely disagree with that. I suspect that in his code, I suspect that any object-oriented designer could look at his code and say that and would agree that it's well designed. And so I, at one point in my life, thought I invented the Law of Demeter. I did. I thought I invented the idea that message passing was the most important thing about object-oriented design. And I can tell you why. It's because I was ignorant and uneducated. But it didn't mean I wasn't writing good code. Because object-oriented code, OOP will teach you to write good code. Like if you make, no matter what you call them, you commit Demeter violations long enough and your code is hard to maintain and you learn not to do it. And so I was doing a rant one day with somebody saying, oh, this thing about you have this, like it shouldn't be over there, you should not here. And she was like, oh, the Law of Demeter. And I was like, what? It has a name? Really? Really? So for good programmers who've written object-oriented code for a while, if you look at their code, it is probably well designed. But they're not using the official academic design words for it. They're not saying it has a single responsibility. They're not saying it obeys the Liskov substitution principle. So those guys, to me, the really good programmers, the people who we think well of, who complain that design is a bad idea, they are not suffering from lack of design. Their stuff is already designed well. However, your stuff, whether code you wrote or code that you inherited, if you don't know these principles or you don't have enough experience, you may well be suffering, and you shouldn't let important people's opinions about this keep you from learning the principles that they are probably already following. So I think design is going to let you lower costs. And so the question about knowing if your code is well designed, even if you don't know the rules, let's say you don't know anything academic about object-oriented design, there's a simple metric that you can use to tell if your code is good enough, and that's your velocity is constant. If every time you come to your app, you need to make a change, it's just as easy as it was last time, then you're good. You're good to go. You don't need to do any more. It's good enough. Changes stay easy. And this morning we were talking about, there's some app where eventually, if every change makes the next change cost more, and you're constantly in there with a machete, like thwacking at code and changing all your tests and changing all your code every time they ask you to make a change, you eventually come to the point where it's easier to rewrite everything than to change anything. You know that your code is poorly designed. But even if you don't know anything about design, if it's working for you, just keep on doing it. Sometimes, however, some people say that design raises costs. So these are the ways in which design raises costs. One is that you don't know enough, and the arrangement of your code interferes with your ability to change it. The other thing is that you anticipate the future, you guess the future, and in this case, it's your anticipatory code adds cost to your desire to change it. Now, here's the first canary. And you probably have this experience already. You're sitting there pairing. You're writing tests, you're writing code, you're writing tests, you're writing code. You're in this state of flow, right? You know what you're doing. It's pretty obvious. And then you hit this wall where you start talking. And you're talking. We can do this, we can do that, maybe we should do this, maybe we should do that, right? All of a sudden you don't know what to do next. And so what you found is that you're at a place where the spec is uncertain. What it means when you start talking and can't do is that you don't know what to do. And that is as useful a piece of design information as the hardest spec on the planet. What that means is you should be really careful and write code that's easy to change, because it's gonna. And so you can find, like, as long as you've got flow, just write the code. But as soon as you don't know what to do, step back and try to be careful and inject your dependencies. Try to be careful and loosely couple things. Try to be careful and give objects small responsibilities, because you can be guaranteed that you're wrong and that the future is going to arrive and then something is going to happen that you can't anticipate today, and you're not trying to guess the future, but you're trying to be flexible so that when you get more information you can easily make changes. You don't want to have to rewrite all your tests and change all your classes when that day comes.
Does that embrace uncertainty? It contains design specifications?
Yes. Yeah. Because here's the thing. It's like, I've spent my whole life going to meetings where programmers said, we can't write that, we don't know the spec. They can't tell us. That happened this morning with what do you want to do if Twitter's not there? What do you want to do if Facebook's not there? Right? And what I would tell you is, that's the best spec you're going to get. Right? It's a spec. That specification says, you got to do something and they're going to want to change it when they see it. Like, make YAML files with data in them to drive the choices. Don't get too tightly coupled across those objects. Like, the guarantee that they're going to want to change it when they see it is the bargain that we make with Agile. But what it means to you is that you have to be really careful in those parts of the code, because they're going to cost you money later if you don't take, like, mostly you can ignore design. It's what you're going to do. What your natural instinct is going to be good enough, but the places where they don't know what they want are the places that are going to cost you a lot of money later if you make commitments. And so design is to let you do design later. It's to keep space between you and the final decision. Yagni says you'll never know less than you know right now. And this place where they can't tell you what they want is the prime example of that. Don't make decisions. Arrange code so that you can easily make decisions later. And the OOD principles, which we'll talk some about tomorrow, we'll talk in detail about ways to do that. But knowing those principles, like, those principles allow you to predict the consequences of the code arrangements you choose. And in places where the spec is highly uncertain, you're going to want to really be able to minimize the consequences of change. So we've actually anticipated this a little bit because of that excellent question. Open-ended design. So how can you tell when things are, so we talked about this, like the programmers talking forever is a sign that you're about to get into trouble and that you should be really careful. So in practice, it's that. This is the conversation that we just had, right? There's an analog. If you're talking around and around circles, you know that you don't know what to do. If the customers are talking around and around circles, you know that they don't know what they want. And both of those are signs that you should be really careful about that pattern of too much talk means you need design. So now, where should you put your design focus? Object-oriented design is about the messages that pass between objects, not about the objects themselves. The conversations we've had this morning have been about what is the role, what is the API. And so your goal is to think about design in terms of the pattern of messages, not in terms of the behavior. It's very often true that you can write any kind of sucky code and hide it behind a method and give it a name, and the name is all that matters. I can preserve my right to make a better decision when I have more information by crafting a good API and hiding the ugly code. I don't really care how embarrassing the code is behind the wrapper, as long as you have a clearly defined interface. If you have a clearly defined interface, you can test the interface and you can substitute a new one. And so it doesn't matter that you don't know how to calculate the thing, or that you're calculating three things and all the code is, there's a bunch of duplication and it's messy code. I don't really care. Very often, there's no good way to fix that problem until you get more information. And so design says, design is what allows you to punt. It's like icing in hockey, right? Or punting in football. Design allows you to hide the mess while preserving the interface in a way that won't have downstream effects when you make changes later. By definition, the API is stable and the implementation is unstable. And so you want to arrange your code so that you have stable APIs that both your tests and your other code can depend on. Right, so you can see I'm like giving you tiny little bits at a time. I can see that later I'm going to open this up. Okay, so it's so hard to explain, like how do you tell somebody what a good app should look like? What does it feel like? Like it's impossible to have that conversation. Like I have this 3D visual image of what my running instantiated app looks like. So where the object, it's like a pinball game, right? Where the objects are bumpers and the ball is going around. And I think everybody probably has their own mental image. It's really hard to, very often when people teach you design, they teach you some principle that you're supposed to follow. It's like, well, great, so I should just do this all the time like an idiot, right? Like a little drone. So much of the way we talk about design is, I find, not helpful. However, the things that we're trying to do in our code, the ways in which we get in trouble in code are about these four things. Dependencies will ruin your life. Dependencies between objects make code hard to change later. A big part of design is managing dependencies. Responsibilities, breaking objects, having objects serve a single purpose, makes them easier to deal with later and reduces the consequences of change. Boundaries, if you're a carpenter, if you're building a house and you have two carpenters and you tell each of them to make a room, what you want is the doorways to be the same size and to line up. Like the ways in which you talk, it's the space between objects that matters. It's the space between them, not what's in them. And so I don't care what's in the room, but the doors have to fit and they have to be the same size and in the same place. And there has to be some overall agreement in the system about how you do that, how you manage that space between objects, how wide that space is, how big it is. And so if you don't manage boundaries correctly, you end up with a bunch of objects that can't talk to one another. The fourth thing that you're trying to deal with that you want to manage in your code base is you want objects to have a minimal set of context. If they have too much context, you end up instantiating 40 classes in order to run a test. If you have too much context, what you're saying is, I have an object, maybe the object seems to have a single responsibility, but it can't be reused anywhere else. It has this very rigid, brittle version of the world, and the world has to exist that way every time you use it. And so if you could write an app, if your apps could have, if they could inject their dependencies, okay, the four things you're going to see in green here, I'll open them up. Steve Freeman and Nat Price said this in a talk once. I've never seen it written down, but I think of this as the best way to describe a good object-oriented application. And some of these words I realize are a little bit academic and may not have strong meanings for you right now, but I want to teach them to you, and I want you to go and tell others. Loosely coupled. Classes are not bound together. I can substitute across the boundary of anybody who plays the role. So I know my API, and I know the APIs of all the objects I interact with. I can plug and play anywhere. They're loosely coupled. I'm going to inject my dependencies both in the production environment and in the tests. In the whole, okay? So loosely coupled. Highly cohesive. Cohesion is that quality of, well, cohesive means like sticky, right? So cohesion, highly cohesive is that quality where everything in a class is related to the class itself. It doesn't do a bunch of different things. It has a central purpose, and all the stuff in it is related to that purpose. Easily composable, all the doorways match. They're all Legos. There's a bargain about the interface, and it's used system-wide. Context independent. I don't really need the whole world to be a certain way in order to work. If you wrote the behavior, it's in an object and you can plug it anywhere that believes that the object it got has that API. Loosely coupled, highly cohesive, easily composable, context independent. This is why we have rules for object-oriented design. The rules are not ends in themselves. The principles mean nothing. They are ways to achieve these goals. You can call what you do in your code anything you want, but this is what you're striving to achieve. So in order to achieve this, you need, oh, that was kind of a mistake. Come back. So in order to achieve those things, you need to know a few things. You either have to know the principles of object-oriented design or have discovered them for yourselves. That works too, right? So you got to know not to violate Demeter. You have to know that you have to have acquired the feeling that classes should just do one small thing, right? You have to, I mean, there are more complicated ones, but yeah, you can teach yourself all the rules. I don't care what you call them, right? But you also have to have two other things. You have to have the ability to write tests that save you money instead of costing you money. And you have to have refactoring skills. And when I say refactoring, I don't mean refactoring. I mean what Martin Fowler talks about, refactoring as changing, rearranging. It's a rearrangement of code that doesn't change behavior. Right? So I have code, it's arranged in some way. I'm going to rearrange the code in a different way to allow me to then change the design. And so if you have testing, OOD allows you to arrange code. Testing allows you to refactor into a new arrangement. I'm going to say that in a different way. Testing allows you to refactor into a new design safely. And so these three things are a three-legged stool upon which all good code rests. And if you are missing any one of them, then you can't change your code. You're going to have to just talk among yourselves in these breaks. So now, so that's sort of the academic thing. But in practice, the way you do design, the how of design, is that if you can't, so here you are, you're writing code, you think, like, there's been a lot of research in the last 5 or 6 years about consciousness and your unconscious processing power and your conscious processing power. It's really interesting. So you can think of your unconscious brain as this huge big cake, and consciousness is a thin veneer of icing that acts as your press agent and explains things. And so it's very often true that you have a feeling about code that you cannot articulate. And in some places, people would tell you, oh, if you can't explain it, it's not real. But what I'm here to tell you is the research shows that your unconscious is way smarter than your conscious. And unfortunately, the only way, it doesn't have words, it just has feelings. So the only way it can communicate with you is by telling you that something feels bad. And if you're looking at code and it makes you feel bad, you should do something about it. Now the problem is very often, your unconscious brain is not all that good about telling you exactly what to do. It just keeps making you feel bad, right? So, and so there's this very simple strategy for dealing with it. It feels bad and I don't know what to do. Break it into smaller pieces. That's all you need to do. Rinse and repeat. Break a method in half, break a class in half. Just break them into smaller pieces and inject them in each other. What happens if you break things into smaller pieces is that, here, I'm just going to give up. And if you break things into smaller pieces, it's somewhere, it'll open up later. See, okay, there you go. If you break things into smaller pieces, what you're doing is you're making an API. You break them into smaller pieces, you give them names. Names are what matter. Names are one of the hardest things. What did they say names in? What was the other one? The two hardest problems? Names in?
Boundary conditions?
Oh, the two hardest problems in computer science. One is naming and one is indirection or something.
Cache and validation.
Cache and validation, thank you, yeah. I mean, the naming problem, if you can solve the naming problem, if you can give everything a small enough name, a real name, a name that identifies the role, a name that's part of the API of the role, your problem is solved. It truly is. So when you get to where you can't, if you're unhappy with your code and you don't know what to do, just make smaller pieces. Divide it and give it new names, and clarity will come. You don't have to know where you're going to use good design practices to get there. And this, if you can refactor and you can make things smaller, what you'll find is that you get clarity. I'm just gonna, since I'm having such a hard time going back and forth with the mouse, I'm just gonna fling forward on the diagram. So you notice that testing and refactoring, like these skills down here under the hows, tie right into the where of design. When you don't know what to do, you break it in smaller pieces, you're defining the API. When you test and refactor, those are the things that allow you to hide the mess. And so if you have, throw messes behind a wall, give it a good name, and just keep on going. Let me go right. Doink, doink, doink. I'm going to go one more time back to my notes. Oh, yeah. And so what we want to do in practice is we want the most cost efficient way to write apps. And so even though I'm thinking about design, we don't do it all the time. You do it really when you notice that there's risk. Risky places where you don't know what to do, places where the programmer's talking around in circles or the customer's talking around in circles, are opportunities to either lower your costs or to raise them. If you deal with risk by guessing, you will raise your cost. If you deal with risk by using the principles of object-oriented design to arrange code so that you can predict the consequences of changing it later, you'll lower your costs. So I think of this whole map. Let me see if I can get it down here. So this is design. Design is how you arrange your code. It's a big tent, and we're all in it. The people who say that you don't need design are not having any trouble maintaining their code. And if they tell you that design is bad, you can ask them what they mean by it, and when they tell you it's because people use design to write overly complicated code, you can agree with them that that's bad. You don't have to have, we're not having a fight, you don't have to have that dispute. But what I would tell you guys, and we'll talk about it tomorrow a little bit, we'll get into the specific strategies some tomorrow when we talk about the book. If you're finding that your costs are going up and that your velocity is not being maintained for apps that you come back to later, there is a solution, and it is in the principles of object-oriented design. We're standing on the shoulders of giants. Really smart people wrote code a long time and figured out what, they just measured things. If I do this, my costs go up. If I do this, my costs go down. And so you can use the principles that those guys have discovered. You don't have to, you can be like me and figure out Demeter all by yourself. Or you can just learn a few things about design and to leverage off their efforts to improve the experience you have later with your apps. Okay, there you go, Mindmap. Questions? None.
I was an evangelist of all this before I started talking. Fantastic.
Well, I love the Mindmap. It's like,
cool.
To me, it makes a compelling argument that lets you talk. Well, lets you talk to people who say, like, I'm really interested in defining design in a very narrow way, right? Arranging your code, understanding the consequences of your code arrangements. Like the flame, the banner I want you guys to carry is like, oh yeah, like you shouldn't write extra code. Don't blame it on design, right? Don't blame it on design. Like we're not taking it.
Can you elaborate a little bit on dependency injection in your objects?
Yes, and I can talk about it now, or we can talk about it tomorrow. So let me just say this. It's a problem of context. Well, okay, knowledge. Knowing something about another object. Why do we care? Why is that a problem? So a dependency is something that if it changes, you might be forced to change. That's all there is to it, right? If you change, I might change. And so what you want to do is have as few dependencies as possible. Because that means change doesn't ripple out across your app and force you to change everything else. And so having one really common kind of dependency is having a class know the name of another class. If you do that, what you're saying is, oh, like I said before, like I want to depend on a role and its interface. I want to have some bargain about what message I'm going to send and have you honor it. Well, if I know the name of the class, I won't talk to anybody who implements that role. I just talk to you, right? And I can avoid. There's a very simple technique. Like if I just instead of having hard coded the class in, if I just like send it as an option on the initialized constructor, then all of a sudden, like we saw real gains for that this morning in the testing. Like the test got so much simpler when we said, instead of I know I'm going to get an instance of this class, I would say, well, I'm just going to get an instance of this thing that somebody passed me in initialized time, which by the way I set as a default to that class. Then all of a sudden I can collaborate with anybody. I can inject a mock or a double in my test. Like the whole world gets simpler when you do that. What it does is it minimizes context in a way that like loosely coupled, right? I uncoupled those two classes by making them know less. They got, when you inject a dependency, the class that's receiving the injection knows less and can do more. And that's a bargain. You should take that bargain. Like I would tell you as a blanket rule, like I'm not a big fan of blanket rules because I break every rule I would give you. Like if you look at my code, there would be some place in my code where I break every rule I would ever tell you, right? Because we just want to get things done. I mean, we want to get things done in the most cost-effective way. And maybe sometimes breaking the rule is the right way, so just do it. But if I were going to give a blanket rule, I would say never hard code the name of a class in another class. There is almost no excuse good enough for that. And it's one of those things where it's a choice about how to arrange code. Doing hard coding the class inside or injecting it, the difference in cost of doing those things when you make the initial choice about how to arrange code, the initial cost is a wash. It costs you almost nothing more to inject than to know. And there's a whole body of choices like that object-oriented design would tell you, instead of arranging it this way, arrange it that way. It's free. And you get benefits later in one case, and whereas you only get costs later in the other. So those are times when I would say, like, that's a bargain. Like, learn that rule and do it all the time. Never hard code another class again. Inject that dependency.
So the mechanics for doing that are so complicated in statically typed languages.
Yeah.
Though. I mean, like, I've been doing a lot of Objective-C programming now, and I don't find that the trade-off is worth it. You know,
Probably
to have
not.
an abstract factory.
I don't use those
or
static
something like that. I mean,
sorry. No, I truly believe like dependency injection or dependency inversion, which is kind of a different thing, and the whole idea of having factories. Like there's a lot of people in the object-oriented design community that curse and spit when you say those things, but it's because they have this PTSD coming from the statically typed languages where they are really hard. It's hard to do those things, and in the marginal edge cases, they may not pay off. Like if I'm saying, oh, you know, I want you to inject a role because you might have different players of that role later. Well, that's a future statement, right? I want you to inject the role because you might have future players later. And so in a situation where the likelihood of having that is very, very low or completely unknown, if there's a high cost of setting up code that way, yeah, you probably shouldn't do it. Right? You should probably inject them when you get a second need or a third need. But in a language like Ruby, where it's really free to arrange the code that way to begin with, there's just no reason not to. Like, learn the techniques and use them because it's the same in the present. I mean, the only difference in cost is in the future, and the only thing that happens is your costs go down.
so I would almost argue that the duck type programming that Ruby encourages you to use can lead to poor really, really quickly.
Yeah.
And it sounds like
Can you repeat the question?
Oh, sorry.
So it wasn't a question, it was a statement. I was arguing that that Ruby's duck typing encourages poor OO, I think, and particularly if you're, if you are inverting dependencies or injecting them, you can get to the point where you're like, well, I expect whatever's coming in to respond to this message.
Yeah, what is it?
And that's its own form of coupling. I mean, so this is one of the things I really like about Objective-C is the fact that interfaces are formal, and I can declare that this object must conform to a protocol in order for me to be able to interact with it properly. And so the lack of that in Ruby is something that drives me crazy. And I think in Objective-C I actually find freedom in the constraints.
Comforting.
Sure. I mean, I know with certainty that this is going to work, and in fact, to the point where I probably can't write working code unless it's good OO.
Yeah. So I can respond to that a couple ways. When I wrote Smalltalk for many years, and then I went to Java, and it took me a while to figure out what that interface thing was, and then I realized, oh, it's a way to make public the API, and that was really cool. I mean, I had that same feeling. It's like, this is really, like, being forced to be explicit in a way that maintainers who come behind you understand the roles that you're using was a good thing for my code base. And it is absolutely true in Ruby that if you are not 100% explicitly clear about what your roles are, that it can be absolutely baffling to look at code and know what's going on. And my solution to that problem is so the problem is the roles are invisible. Right? The roles are invisible. There's no interface that says, I conform to this. And so in my code, everything is a role, but I write tests for the roles, and I include those role tests in every object that plays the role. And so, and you have to do that, because there's no other mechanism in a dynamic language like Ruby to communicate the existence of a role. And so in RSpec, there's like a, behaves like a, what is that in RSpec? Like there's a way to share test.
Should behave like.
Should behave like. So, there's a really cool thing in RSpec. The first time I ever saw this was in RSpec, where writers of frameworks who, they would have a framework that expected to receive an object from you that honored some API. And in order to keep you from screwing up, they would write a should behave like. Should behave like. So they would write this test, and they would say, include this test in your object, and then you'll know it conforms to this interface. And it was like a light bulb went off in my head, right? That's the solution to the problem of invisible interfaces. You write a test, and that in mini tests, you just write a module and you include it in the test. In RSpec, you do the should behave like. And so you have a place in your test suite that said, here are the roles in my app. And any object that plays any one of these roles better include these tests to prove it conforms to the role. And then I know what I'm doing. The nice thing about doing it that way is that, one of the problems with testing with mocking and stubbing is that it's really easy to create that alternative universe where your tests run but your code is broken. And when you think about the reason for that, it turns out that the reason for that is quite simple. Like when you stub a whole object and you put some methods in it, what you're doing is you're creating a player of a role. You're creating a player that should honor some interface. And when you change the actual code in your app, but you don't change those guys, what you're saying is the role got updated, but all the objects that play it do not conform to the new interface. And then your tests tell you, oh yeah, it's good, everything's right, and then the app blows up at runtime. If you make a practice of creating role tests, you can include them not only in the objects in your app, but you can run those tests for the mocks and stubs, right? If I make a stub that plays some role, I put the role test in the stub, and then the stubs blow up when that role changes, and every role player doesn't get updated. And so writing a test to document roles solves the documentation problem, and it also solves the brittleness in testing problem, and it allows you to sort of freely use mocks and stubs in a way that feels safe, where it's useful in your app.
So do you have any advice for how to propagate that going forward? New developers come onto the project, they don't know that this is a convention of implementing this interface by, proving you implement that interface by the test.
Hopefully if they look at your test and you're like, so now we're back to that next thing about how you make people behave in ways that's good for your code base instead of ways that are going to harm it. And the easiest way to do that is to write code where making changes any other way is hard, right? Like if your code has a very strong pattern where the natural extension of it for someone that doesn't know what they're doing is to do what you did. And so it is to be hoped that they'll crib some other test that's there. And that test will be like this.
So in absence of tests, what a lot of people will do in situations like that where they want to enforce a interface in a language that doesn't have a formal notion of that would be like to raise when a method gets called. So adding tests to the equation, would you say that something like that where you're kind of enforcing the notion that, say if you're going to implement this, you have to overwrite this method, or if you're subclassing it, like there's going to be a ramification in the actual
I
code.
do that. Like especially in cases of inheritance, where I require, like I'll either, like if I'm using the template method pattern, does everybody know what that is? So I have inheritance and the superclass is sending messages it expects the subclass to override. If there's a standard default like an empty hash, the superclass could implement it. But if it's a thing that I require the subclass to answer, I'll raise a subclass responsibility. I mean, I'll blow up and I'll test that in my tests, I'll test that the superclass throws that error and that subclasses implement it.
Okay.
Like there's a whole, actually it might be interesting for folks, if you want to talk more about testing, we should look at chapter 9 of the book together because every one of these issues is in there.
Okay.
And some of them I made up, some of them I feel more confident about some of the suggestions than others. So it would be interesting to talk about it and to get, to see what you guys think.
Okay.
But roles. I love, I find statically typed languages almost painful to work in. But I completely agree that like your obligation in a dynamically typed, if you're going to use the power of dynamism to create ducks, you've adopted a new problem, which is conveying your intentions to the programmers who come behind you. And the burden is on you to make that clear. Or people, like you can't say when people come in and write bad code on top of you, you can't say, well, I was designing well and then they wrecked my code. Like that is never acceptable. My life got a lot better when I realized that instead of being pissed off about people ruining my designs, I should just do better designs. And so there is a level of code, there's a set of code that you can write that is intention revealing enough to make the people that follow you do what you want them to do. And often it's one step more than what you're doing now, but I can really recommend it because it just made me happier all around. Anything else? So are we done? Thanks.
So one question I have is for object-oriented design, I feel like it's a continuum. So on one end, you can have a very, very little design. And on the other end is, you can follow all these patterns or really make the effort to make it flexible and so on. And when we do coding, when we write code, there are a lot of considerations. There's business considerations. There is, time and so on. So, I'm not looking for an answer, just sort of listening to your.
So should I repeat that question for Chicago? So he wants to know, like, where do you draw the line? There are lots and lots of principles and patterns of design, and you could spend your whole life writing perfect code. You could spend your whole life trying to write code that you thought a master OO designer would like. And I'm very practical. Like I'm not an academic. I have a psychology. I'm a failed music student with a psychology degree that's been writing code for 30 years. Right? I just want to get code out the door in a way that costs me the least amount. I'm going to provide the most features for the least cost in the right time interval. And often that means making choices about where you're going to hide ugliness and where you're going to stop for a minute and spend a little time thinking about the future. And so the future, you have to think about the future where you don't know the spec. That's all you care about. Right? If it's because it's where it's going to change that it costs you money to not have the code be arranged right. So for me, like, pay attention to what hurts later and think about why. I didn't inject my dependencies. There's too many responsibilities in this class. I mean, those two things, making smaller bits and breaking the coupling between them apart will take you almost as far as you need to go. Don't guess the future. Just make sure that when you know you're guessing, step back instead of stepping forward when you don't know what to do. Do less instead of more. Don't make decisions. Preserve your ability to make decisions later in places where there's high uncertainty. So I would say, write code, get it out the door, and when you find that, if you're rolling, just keep writing. And if you start doing that, back up and leave yourself some room to move.
Right. So I find myself when I write code, there are situations where I feel like I can really do some refactor here, or I can just keep going, and then if it's really a problem, I'll come back to refactor.
I often don't refactor until the third time I feel like it's wrong. Right? 2 is not enough information. Now, if you get in a pattern of writing smaller things, the refactorings are easier. Like, most of the refactorings I do are a matter of minutes. And if your test tests the API and not the implementation, you don't break your test when you do a refactoring. And so there's this sort of whole sort of constellation of things. Like, there's an environment, if you can get to it, where small refactorings and improvements in design are easy. But there's also this place back at the front, like, when I first, people said, write tests. You should do tests first. And we were like, oh, it's okay, so we'll write tests, why not? And then I went and looked at a massive Smalltalk code base, and guess what? It was freaking impossible. Like, we couldn't put test 1 on that code base. And it's because it was incredibly tightly coupled, right? It was like, there are many things about, like, tests are reuse. Tests are the second case, right? Your code uses each other, and the tests use it. And so what you find is that your code is absolutely unreusable if you cannot put tests on it. And so having, getting in a situation where you just write smaller things, and then if you get to the situation where you can refactor without breaking all your tests, like, that's a good goal. Make your tests against the APIs, and then as soon as you get to where you can refactor cheaply, you'll do more refactoring. And so if you find that it's hard to refactor because it seems like when you reach in and grab a piece of your app and pull it, half the app comes with you, it's very hard in an existing app to fix that all at once. It's a matter of nibbling around the edges. And so you pick your battles. If it's working and they're not going to change it and it smells really bad, you might not care. But when, the goal, Bob Martin's goal of, like, leave it a little better than you found it, right? Leave it, when you make a new, like, if you have to make a change and you find that when you reach in to add that change, you pull and 3 or 4 threads come with you, maybe you break 1 of them, maybe you break 2 of them, right? You do a little bit every time you touch it, and eventually, either it stabilizes and they quit asking for change, in which case, no matter how bad it is, it works and you should leave it, right? Really, we're talking about money here. It is about money. It's about the business value. Like, your customers don't care that it's ugly. All they want to know is if it works. And they want you to be able to make the next change without breaking the bank or rewriting the app. And so, use your best judgment. Very often for me, what I wish I could do and what I end up doing, I wish to do something that's a little bit more saintly than what I actually do. What I actually do is a little ugly and dirty. And I don't care, because I'm spending somebody's money every time I write on code. So yeah, do enough to lower costs for your customer, and that's really it. And that's a judgment call, but they pay you to make it. That's why they pay you the big bucks, because they think you're doing right by them at that decision point. Are we really done now? Okay, thanks guys.